In the last episode, I guided you on how to choose the right LED strip for you. And at the end, we went over the different types of controllers out there. However, in this episode, I will teach you how controllers work and how you can build your own smart LED strip controller for less than $10. If you missed last week's episode, you can find its link in the description below. Now, without any further ado, let's get started. First, let's start by understanding how the simplest controller controls the brightness of the LEDs. So we know that a LED needs 3 volts to turn on, and you might think that the controller would simply vary its voltage to control the brightness of the LED. However, in real life, controllers use something called pulse width modulation, known as PWM. PWM is a square signal that will turn the LED strip on and off so quickly that it will give you the illusion of a change in brightness. To understand how PWM works, let's suppose that it has a period of 1 millisecond. If in this millisecond, the PWM is high for half of the millisecond and low for the other half, it will give the illusion that the LED is on at 50% brightness. If instead the PWM was high for 1/4 of the millisecond and low for the other 3/4, it will give you the illusion that the LED is on at 25% brightness. This fraction of the period in which the PWM is high is known as the duty cycle, and the larger the duty cycle, the more electrical power gets delivered to the LED, which makes it brighter. Next, let's understand how colors are made. We know from the last episode that multicolored LED strips, known as RGB, are formed of red, green, and blue LED strips merged together. But how are you able to create other colors, such as yellow, orange, or purple? Well, actually, you can mix the RGB colors together to create new ones. If you want any specific color, you simply need the right recipe, with the right amounts of red, green, and blue. For example, if you want purple, you need to mix red and blue together. And to get different shades of purple, you simply change the amounts of red and blue. In fact, all color displays use RGB lights, even your TV, laptop, and smartphone. Now, in order to mix different amounts of red, green, and blue, you simply need to vary their brightness. Oh, and guess what? We just learned how to do that using PWM. Now, let's design a hardware that can produce this PWM signal. And to do so, let's go to the workshop. The easiest microcontroller out there is the Arduino. And for this project, since I want to make it as compact as I can, I will be using the Arduino Nano. But the Arduino can't provide enough power to drive the LED strip, because it is a 5-volt device and can deliver a maximum current of 20 milliamps per pin. This is why we need something that would convert the 5-volt low current signal of the Arduino into a 12-volt high current signal. The easiest way to do that is by using MOSFET transistors. For those of you who don't know what a transistor is, well, actually it's an electronic component that works just like a switch. But the difference is that instead of switching it using your finger, you use an electrical signal. When selecting a transistor, there are 3 things to look at. First, the series of the transistor. For this project, we will be using an Arduino, which provides a 5-volt signal. This is why we need a logic transistor known as IRL. Next, we need to choose between an NPN and a PNP transistor. NPN transistors are normally open and closed when they receive an electrical signal, while PNP transistors are normally closed and open when they receive an electrical signal. Since in this project we will need to mimic the PWM signal, we will need a NPN transistor. Finally, we need to make sure that the selected transistor can handle the voltage and current requirements of our LED strip. For this project, I will be using the IRL 540, which is rated at 100 volts and 28 amps, more than enough for my 12 volt 2 amp LED strip. Now, to control the LED using a transistor, you simply need to place it between the LED and the ground, and connect its gate to one of the PWM pins of the Arduino. With this configuration, the transistor will mimic the PWM signal of the Arduino by connecting and disconnecting the ground from the LED. However, to prevent the transistor from floating, we will also need to place a very large resistor between its gate and the ground. For this project, I used a 750 kilo ohm resistor, but any resistor larger than 100k should be enough. Finally, the simple circuit needs to be replicated 3 times, 1 time for every color of the RGB LED strip. Now that we have designed the circuit, let's build it on a breadboard and test it. But before that, I will add a heatsink to my transistors. A small DIY tip I have for you is to stick a magnet to your screwdriver. This will magnetize its tip and prevent the screws from falling off. To test the circuit, I already wrote a simple Arduino sketch that will flash the 3 colors of the RGB. You can download this sketch and the official Arduino software using the link in the description below. To upload a sketch on the Arduino, you need to select from the Tools menu the type of board you are using and the port it is connected to. After that, simply press the Upload button on the top left of the Arduino IDE. You should now see your LED strip flashing. If for some reason the circuit doesn't work with you, test its continuity. I've spent 2 hours debugging my circuit to finally find that one of my jumper wires was broken. Now that we know that the circuit works, I will solder it on a perf board, since it is the simplest and fastest way to solder the components together. With the circuit complete, let's get back to my bedroom and replace the old LED strip with this new cool one. Also, I need to place the controller somewhere accessible, so that I can still connect it to my laptop and upload new sketches to the Arduino. Whoa, this is much better. Look how continuous the light is. But the flashing is quite disturbing, so let's get to coding. After plugging a USB cable into your Arduino and getting comfortable on your laptop, open the Arduino IDE. Once you open a new sketch, you will see that there are 2 main sections: the void setup and the void loop. In the void setup, you initialize your code. For example, you tell it to make sure that all the lights are off. And then, in the void loop, you tell the Arduino what to do repeatedly, like flashing one color after the other. For this project, we need to first tell the Arduino which pin is what color. Then, using the analog write function, we can tell the Arduino the value of the PWM that we wanted to generate. This value should range between 0 and 255. 0 turning it completely off and 255 turning it completely on. You can also use for loops or delays to create special effects, such as fading or flashing. To save you some time and effort, I already pre-programmed many common LED strip functions that you can download using the link in the description below. Also, if there's any specific function that you need help with, share it with me in the comment section below, and I will be glad to help you. So the LED is installed and can do cool animations, but there is still one problem. Every time I want to change something, I need to get my laptop and plug in a USB cable. This is why next week, I will show you how to control an Arduino from our smartphone. So if you don't want to miss this episode, make sure to subscribe and push the notification bell. In the meantime, you should enjoy one of the videos on the screen right now, and I will see you next week.